Good morning, friends. Study material session 31. In this session, we shall discuss about the problems of Karl Pearson's coefficient of skewness. The first one, find the coefficient of skewness from the following data. They have given the two series, value series, frequency series. Heading, we have to write it as the calculation of Karl Pearson's coefficient of skewness. We have written 6, 12, 18, 24, 30, 36 and 42 in the first series as we assumed the value will be X series. And then frequency, it is the F series 4, 7, 9, 18, 15, 10, 5. 15, 10, 5. We have written the X series and the F series. For the SKP, the formula for the SKP is mean minus mode or standard deviation. We have to calculate the arithmetic mean, then mode and standard deviation. Here first we shall calculate the arithmetic mean. X bar is equal to A plus sigma FD by N into I. Here we have to take the deviations first. The deviations has to be taken from the assumed mean. 24 is the assumed mean. Here x minus 24, 6 minus 24, it is the minus 18 divided by 6, it is equal to minus 3. Then 12 minus 24, it is 12 minus 12 divided by 6, it is equal to minus 2. 18 minus 24, minus 6 divided by 6, it comes to minus 1. Then 24 minus 24, it is equal to 0. 30 minus 6, it is the 6. 6 divided by 6, 1. 36 minus 24, it is the 12. 12 divided by 6, it is equal to 2. 42 minus 24, 18. It comes to 18 divided by 6, it is equal to 3. Then we have to square the deviations. It is the minus 3 into minus 3, 9, minus 2 into minus 2, 4, minus 1 into minus 1, 1, 0 into 0, 0, 1 into 1, 1, 2 into 2, 4, 3 into 3, 9. Then we have to multiply FD 4 into minus 3, because in order to apply the arithmetic mean, we have to use the formula. It is the A plus sigma FD by N into I. FD, you have to multiply the FD first. Then that it is the deviations which has been taken from the assumed mean, and then square the deviations. Then FD 3 into 4, minus 3 into 4, it comes to minus 12. 7 into minus 2, minus 14. 9 into minus 1, minus 9. 18 into 0, 0. 15 into 1, 15. 10 into 2, 20. 5 into 3, 15. So this is about the FD. Total of the FD, it comes to 15. 12 minus 14, 26. 26 plus 5, 35. 35, 35. 15 is the sigma FD. Now we can apply the formula for the arithmetic mean. X bar is equal to A. A is assumed mean as the 24. Then sigma FD, it is the 15. And total of the N, 4, 7, 9, 18, 15, 10, 5. It comes to 68. N is equal to 68. Here we have been taken the common factor as the 6. You have to multiply the 6. Then X bar is equal to 24. 15 is the sigma FD. And N is equal to 68 into common factor 6. 15 divided by 8, 68 into 6, it comes to 0.22. Into 6, it comes to 1.32. 24 plus 1.32, X bar is equal to 25.32. After getting the X bar as the 25.32 for the applying the coefficient of skewness, we need the standard deviation as well as the mode. For that, we have to use that mode is the highest one. Here the highest frequency is 18, 24 is the mode. Mode is equal to, it is the 24. 24 is the by inspection method also. We can determine the mode 24. Arithmetic mean is 25.32. We have to find the standard deviation. For the standard deviation, the formula is square root of sigma f d square divided by n minus sigma f d by n whole square into I. Sigma f d square you have to calculate. For that, d square has to be multiplied with the f. 4 into 9, 36. 7 into 4, 28. 9 into 1, 9. 18 into 0, 0. 15 into 1, 15. 10 into 4, 40. 5 into 9, 45. Total of the FD square 36 plus 28 plus 9 plus 15 plus 40 plus 45. It comes to 173. Sigma f d 15, sigma f d square 173. We have to apply in the formula of the standard deviation. It is the square root of sigma f d square 173 divided by 68. N is equal to 68. 15 is the sigma f d divided by 68 whole square into I, that it is the common factor here. Standard deviation is equal to square root of 173 divided by 68. It comes to 2.54 minus 15 divided by 68, 0.22 whole square. It comes to 0.05 into outside 6. Then deduct the 2.53 minus 0.05, it comes to 2.48. Root of 2.48, if you remove, you will get 1.57. Then outside 6 is there, you have to multiply 1.57 into 6, so that you will get the standard deviation as the 9.42. Hence the maximum frequency is that it is the mode is equal to 24. Now we have to apply the formula for the skewness. Carl Pearson's skewness, according to him, skewness it is equal to mean minus mode over standard deviation. Here mean is equal to 25.32 minus mode is equal to by inspection method the highest frequency corresponding to it in the variable 24. 24 is the mode divided by standard deviation 9.42. You have to simplify in order to get the skewness. 25.32 minus 24, 1.32 divided by 9.42. It is equal to 0.14. Here, coefficient of skewness according to the Carl Pearson in the given problem, it is the 0.14. 0.14. Skewness says about the direction in which the deviation has been taken. Here, the deviation or the skewness according to the Carl Pearson, it is the 0.14. This is helpful for the decision making for the management or the experts who are seeking about the some problems has to draw the conclusions. For this, 0.14 is the Carl Pearson's skewness. Compute Carl Pearson's coefficient of skewness from the following data. Variable 20.5 to 23.5, 23.5 to 26.5, 26.5 to 29.5, 29.5 to 32.5, 32.5 to 35.5, 35.5 to 38.5. Frequency 17, 193, 399, 194, 27, 10. Here they are asking about to calculate the Carl Pearson's coefficient of skewness, that it is the SKP. The formula for the SKP it is equal to, it is the mean minus mode over standard deviation. We have to calculate the mean, we have to calculate the mode, we have to calculate the standard deviation. Here in the continuous classes variable, they have given the variable. We have to find the midpoints. How to find the midpoints here? Add the lower limit and the upper limit and divide it by 2, so that you will get the midpoint 20.52 plus 23.5 divided by 2. It comes to, it is the here class midpoint 22. Midpoint as the 22. Then we have to write the heading, then draw the columns of the class intervals, frequency, then midpoints 22, 25, 28, 31, 34, 37. Frequency has been given. Here deviations m minus 28. In the m 28 as the assumed mean, then 22 minus 28, it is the minus 6. Minus 6 divided by 3, it is equal to minus 2. 25 minus 28, it is the minus 3. Minus 3 divided by 3, it comes to minus 1. 0, 1, 2, 3. Then d square, square the deviations, so that we'll get the d square. In the same way, you have to find the fd and fd square. Total of the fd is 51. Total of the sigma fd square 653. We have to apply the formula for the mean. Mean it is equal to, it is the x bar is equal to a plus sigma fd by n into I. By applying this formula, we get the x bar as the 27.82. Then we have to calculate the standard deviation by applying the formula. Then we get the 2.64 as the standard deviation. And here in the mode, the highest frequency is 399. When we compare it with the frequencies, the highest frequency is 399. There is no ambiguity or confusion with regard to the which is the class of the modal class 26.5 to 29.5. Here this is the modal class. If we know about the modal class, we can calculate the actual mode where it lies. For that, you have to apply the formula. Mode is equal to, it has been indicated as the Z L lower limit plus f1 minus f0 over 2f1 minus f0 into ft into I, where f1 is the frequency of the modal class, that it is the 299. L is the lower limit 26.5. f0 preceding term of the modal class, it is the 193 modal class. Here modal class is 26.5 to 29.5. Here f1 399, f0 it is the 193, f2 194. Then here 399 is the f1, f0 193, f2 194. You have to simplify this one in order to get the mode 26.5 plus 399 minus 193 206 divided by 798 minus 193 minus 194 into 3. 206 divided by 411 into 3. Z is equal to 26.5 plus 0.5 into 3. It comes to Z is equal to 28. As we got the x value as the 27.8 and Z is equal to 28 and standard deviation as the 2.64, we can substitute in the formula of the coefficient of skewness, so that we'll get the skewness according to Carl Pearson. It is the escape is equal to negative 0.68. So this is how we find the skewness according to the Carl Pearsons in the different series or different problems. Here we have been referred from the quantitative methods for business, CM Chikkodi, Himalaya Publishing House. Thank you.